We're going to use the unit circle to evaluate the following trig functions. Now, what I would do first, and you're going to really see once we get done with this, and I put down 1, 2, 3, 4, 5 values, that those 5 values are the quarter marks or the quadrantial angles of the circle. And there's 5 of them because 2 pi is the same as 0. So 2 pi is all the way around the circle. Now, these are the ones that should be very quick. And if you have a knowledge of these, you can actually do the next thing we're going to do fairly successfully. But remember, if we're using the unit circle, the radius is 1. So if I go over to the right, 1, up 0, that's the location at 0 degrees or 0 radians, and also 2 pi. And then what if I go halfway, a quarter of the circle, that's pi over 2, and that's at the spot go over 0, up 1. If I go to the left, that's at the spot go over -1, up 0, and notice that is going to be just at pi. And then if I go another quarter, that puts me at 3 pi over 2, and this is at the spot go over 0, down 1. Now, as we talked about last week, the sine value is always the y. Anytime you have an xy pairing, cosine is the x, sine is the y. So what is sine of 0? Well, at 0 radians or 0 degrees, the sine value is 0. And actually, you know what? I'm going to do that in red, just so you'll see. And let's do these highlighted ones because those are the quadrantial angles. Those are the fast ones, right? What is sine at pi over 2? Well, here's pi over 2. What is the y value? That's equal to 1. And then what is the y value at pi? Well, that's 0. What is the sine value at 3 pi over 2? That's -1. And what is the value at 2 pi? That's the same as 0 radians, so the y value is 0. So those ones should be very quick. And I hope you almost you're able to just quick draw this circle if you need to find those values. The next ones deal with the pi over 3, and actually I should kind of flip these around. I try to do it in order. Pi over 3 is 60 degrees. Pi over 4 is 45, and pi over 6, 180 divided by 6 is 30. So I should have actually had those two flipped in terms of just going in order. I wonder if I can do that quick. And the 60 and the 30. Okay, so these pieces here, how do we do this without a calculator? Well, that's where the unit circle comes in. So think about what a 30-degree reference angle would look like. I would draw that about right here. And then this would be the 30 degrees or pi over 6. Now, we do know that we have to find the xy pairing. And this was part of the memorization piece from last week, but I went the longest way here and then up. Now, if you notice, this isn't perfectly drawn right, but I went up 1/2 of the value, and the long way was a square root 3 over 2. So we are hoping that you have enough familiarity with the unit circle that you might recognize these patterns. And if not, that's why we're going over it again. So what is the y value at this location of 30 degrees or pi over 6? Well, it's 1/2. Okay. And then what if I do the 45-degree angle? That's splitting this. It's kind of right in the middle of this part of the circle. Well, that's 45 degrees. And a quick memorization piece of this one, it was always square root 2 over 2 and square root 2 over 2. X and Y are the same values anytime you're looking at a 45-degree angle. So what is the y value? It's square root 2 over 2. And then the very last one, sine of pi over 3. Well, that's the 60-degree chunk, so that's going to be a taller triangle. And one of the ways I like to think of this is if you draw this, you're actually exactly halfway across. So your x value is the 1/2. and then we've got the square root 3 over 2. So there are patterns we talked about last week, and however you remember those, if you know these values here, if you can do all of this, and you know what sine and cosine is, and then you even know tangent. Remember, if I asked you to do tangent of an angle, all you would do is take the sine over the cosine, which in this case was y over x. And you could actually then generate anything in this quadrant, this quadrant, this quadrant, as well as their reciprocals. So just by knowing this information here, that's what you need to have mastered to move on into calculus. Okay, so for next year. But to be successful in pre-calc this year, it's good to know. So why did I have you do all these, right? It's more than just reviewing the unit circle, and there's a connection now to what the graph looks like. All right, and it's up to you. You don't really have to write this part because we're going to go over it a little bit later, but let's look at this. And what if I graph sine of x? So what if I take 0, pi over 6, pi over 4, pi over 3, pi over 2, and I graph all these values. Remember, this is like your x value here, and then your output, this is your y. Now it's different than this x and y. Well, not technically it's not, but we're going to graph this, and here's the way I like to do it. And if you remember this from Algebra 2, we always graphed 4 tick marks, and the 4th tick mark represented 2 pi, which was all the way around the circle. Well, why is there 4 tick marks? Those 4 tick marks are the quadrantial angles. And notice, the highest output, the highest this value ever gets on the y is at 1, and the lowest the y value ever gets is -1. So I'm going to go from 1 to 1, and then I'm just going to put in the values on this graph. So if 4 tick marks is pi, then half of 4 would be regular pi, because I just cut 2 pi in half. Now what if I cut that in half? That's pi over 2. So every tick mark is a pi over 2. That means the one that's missing is a 3 pi over 2. Now I could do the same in the other direction, which I'll do that in a second, but watch what happens now. I'm going to plot just the red values. What is the sine of 0? That's equal to 0. What is the sine at pi over 2? That's a maximum. That's the highest y value. What is sine at pi? It's equal to 0. So we go back to that 0 spot. And then what is the sine at 3 pi over 2? Well, that's a minimum. So I go back down. And then notice, because we go right back and 2 pi is the same as 0, I'm going to end up right where I started, back at 0. Now, we don't technically need to have these graphed, but if I wanted to graph them, this is what it would look like, just roughly. If I go pi over 6, that's like a 30-degree chunk. So that would be like splitting this up into thirds. So this would be pi over 6, I would be at a positive 1/2, so halfway there. And then at square root 2 over 2, that's going to be just a little bit higher. And square root 3 over 2 is just a little bit higher. But notice, what does that do? That sets this trend of what does the graph of pi look like. Now, if I graphed items here, these points would be in quadrant 2. Right? If I just reflected all of these, we could spend a lot of time generating this, but it would give me a curve like that. The points between pi and 3 pi over 2, those would be from quadrant 3. And then the spots between 3 pi over 2 and 2 pi would be here. Well, here is the graph of what sine looks like. Now, we do know that I can go the other direction, right? I can go negative values. If I go to the clockwise 90 degrees, that's the same as negative pi over 2. So 1, 2, 3, 4. If I just quickly graphed this, this would be negative 2 pi. Halfway through would be negative pi. Half of pi is negative 2 pi. And then in between would be negative 3 pi over 2. And all this would be is going around the circle the other way. Well, look at, if I go negative pi over 2, the y value is -1, which follows this pattern that this has to follow kind of this curve. So I went from the midline down to the minimum. And then if I go over to pi, negative pi would be here at 0. Negative 3 pi over 2 would be going all the way around this way until we get to this value, which is 1. That's a maximum. And then getting back all the way to 2 pi, we're at 0 again. So when we talk about the graph of sine, I want you to think of this function, and technically there's arrows here because this is a periodic function. It continues on in this pattern forever. Well, we're going to also talk about one cycle, and one cycle is how long does it take to go back to where it started. So how long does it take to go around the circle once? Well, in this case, it took 2 pi because that's all the way around the circle. So that's just a visual of why we're doing what we're doing and where these points come from today. They come from the values on the unit circle. All right, I don't want you to write this, and actually we're going to just look at it very quickly. What if I wanted to do the graph of cosine? Okay, well, cosine we know is different than sine, and if I have the ordered pairs, this isn't working. If I have my ordered pairs on the unit circle, now I just put this here, but we could generate it, right? We could generate this very quickly. We have the x values at the 4 special quadrantial angles, right? 1, 0, -1, 0. So at 0, when cosine is 0 or 2 pi, my y value is 1. So what is it at pi over 6? Well, pi over 6 is right here, and the x value is square root 3 over 2. What is cosine at pi over 4? That's square root 2 over 2. What is cosine at pi over 3? That's 1/2. What's cosine at pi over 2? Now I'm just hitting those quadrantial angles, so pi over 2 is 0. Cosine of pi is -1. Cosine of 3 pi over 2 is 0. And cosine of 2 pi brings me right around the circle. We're back at 1. Well, notice, what do we have? The highest output is at 0, or 2 pi. That's our max. The lowest output is at pi over regular pi. That's our min. So that tells us a little bit of how the graph of cosine is created. And what we're going to do then is we're going to actually go ahead and draw that. Just quick. And again, I'm going fast so you don't have to write this piece. But what do? We go 4 tick marks. Why do we do 4 tick marks? Because there's the 4 quadrantial angles, and we always end at 2 pi. Now that can change. That is going to change today when we start looking at something called a shift or a horizontal compression. But we're at pi over 2, 3 pi over 2, and I want to just go ahead and graph these the same way we did it before. But notice, where does cosine start? Cosine of 0 starts at the maximum. Sine started at the midline, but cosine starts up here at the max. And then we don't really have to graph the extra pieces. We're only looking at the 4 quadrantial angles. So then where do we go? Cosine at pi over 2 is at 0. We're going to call that my midline, and I'll show you that in a second when I get done graphing this. So I go from the max to the midline, and then at cosine of pi, I'm down here at -1. And then I go right back to the midline again at 3 pi over 2, and then we're back to the maximum. Notice that is considered one cycle or one period. How long does it take to go from the max back to the maximum? Right? And then I could just continue this pattern if I draw it the other way. 1, 2, 3, 4. If I'm at the max, then I would go to the midline, go to the minimum, back to the midline, back to the max. And that would draw the remaining portion of cosine. Okay. Now, some kids like to do this, and I'm going to recommend it. We're going to focus on 2 things, actually 3 things today. we're going to focus on where does this maximum occur, right? Why is the max line that value? Well, the reason why is because the cosine of 0 is 1, and whatever number is out in front here, which right now it's a 1, that controls the max and min in a sense. And we'll talk about that in a little bit. And then same thing down here. If I was to draw this line right at the bottom, there's the minimum, right? If the lowest values go at -1. And these are y values. So if we ask you to write the equation, that would be y equals 1, y equals -1. But then the other important piece is, what about this midline, right? I hit 0 a couple of times. I hit it here, 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 and it's going to keep following that pattern. So the midline is an important piece of this graph as well. We want to view that. So I'll tell you where those all come in, but notice the midline in this case is at y equals 0. All right, so why are we doing this? Well, today's goal is we know the unit circle now. We can evaluate any trig function on the unit circle. And our goal is to kind of take that idea and transform it now into graphs. So we're going to do 4.4 day 1, and we're looking at graphing both sine and cosine functions today, as well as looking at their behaviors. So we kind of have a lot to do today. So here's what I'm going to say. I don't want you to write this right here. Okay? This is in our notes. They're online here. You can access them. If you feel like you won't go back, maybe take a screenshot of this right now and save it to your desktop or someplace that you know you'll make reference back to it. But you'll notice a familiar form here. The A value, B, H, and K. When we learned quadratics, right, we had a value for quadratics that was something along the lines of this, where we had an A, H, and K. We really focused on A, H, and K. The B value wasn't very present in our quadratic forms, but B value occurs quite often with the trig functions and their graphs. So we're think of the B as a new value, but you already should know what the A value does, right? A value controls how wide or narrow something is opened. In this case, it's like a multiplier, right? Because this is A times the function. So A is going to kind of have the effect of the amplitude. It's going to tell us how high a value goes or how low the value goes. So it's going to help us determine where that max and min line are. The B value affects how frequently something is occurring. Now, when we say frequent, how long does it take to do one period? And this is a formula that we're going to be using quite often. And we'll write that on the next slide. But it's just to find the period for any sine or cosine, all you do is take 2 pi divided by the absolute value of whatever the B is. So whatever number B is, we go ahead and do 2 pi divided by that. And that will tell us how many tick marks it will take to get from a start to end, right? From where you started back to where you originally wanted to go, going through a max, midline, min, and following one period. Now we do know that the H value shifts things left or right? But the shift is always opposite of what you think. Okay, remember if I had x plus 3 here, this is a shift to the left 3 units because we would really think of the plus 3 as a minus and negative 3. So we're shifting to the left 3 units. So just be careful on that H value. And the K value is your vertical movement up and down, right? So that's what we learned basically all of Algebra 1, Geometry, Algebra 2. We talked about shifts. Well, what does the shift up and down control? That controls where my midline is present. So the midline is the K value. Okay, so that's our goal today. And again, you'll be able to refer back to this in the notes. What I would like to do is just do a really quick sketch of sine and cosine functions so you get the idea. So definitely write this one down. Sinusoidal. Now, sinusoidal is just a term for a sine or a cosine graph, and they're actually the same graph, except for they change by a horizontal shift. So, here's how I'm going to have you guys graph sine and cosine functions today. Okay, and we're going to start with the parent function. So, label your graph, draw a chart like this, and we want to make 1, 2, 3, 4 marks, just like we talked about in the warm-up. Okay, and that fourth mark is always the period 2 pi. And then for regular sine and cosine, we only go up 1, down 1. Why? Because the unit circle, the highest value was 1 and the lowest value was -1. So that's my max and min line. Okay? And then the next thing I like to do is if the fourth tick mark is 2 pi and I cut that in half, well, that's just regular pi. Oops. Right, so half of 2 pi is pi, and then that means if 2 tick marks is pi, half of that is pi over 2. So every tick mark represents pi over 2 or 90 degrees. So this would be 90 degrees, 180 degrees, 270, but 270 is the same as 3 pi over 2. So that's how you get those 4 marks, but they're just those quadrantial angles that we talked about. So what do you need to know about the sine function? Where does sine start? Sine starts every single time at the midline unless there's a shift or a vertical shift or a horizontal shift. So in our parent function, sine starts at the midline. And then it goes up to the max, and it goes back down to the midline, and it goes to the minimum, and back to the midline. So there's one period. We just graphed one full period of sine. And we want to know, the important thing about this is understanding where the max lines are, where the midlines are, and where does sine start. Sine will always start at the midline. Okay. Then the next thing I'd like you to do, sometimes I do this at the start, but I always draw in my max and midline. And then I also do the midline, because it's very important for us to understand where those occur, and sometimes I even graph those first. The max is at the equation y equals 1. The min is at the equation y equals -1. And then our midline is at the equation 0. Why is it 0? Because I could put a +0 at the end here, and that just means I do not shift anything up and down. So if I did have a k value, if I had a k value that was +8, I would shift everything up 8 units. And that's just how the k value affects it. All right, so we're going to do the same thing for cosine. Cosine, though, as we saw in the other example, because of the unit circle, cosine starts at the maximum. So we're going to set up our graph the same way. We're going to go up 1, down 1. We're going to have 4 tick marks. The fourth tick mark is always 2 pi. You don't technically need to label every one like we did here. I think it's good practice to. But if you label pi and 2 pi, the readers should be able to determine what the other values are. And then as we had seen, cosine of 0 was 1. Right? So that's a different starting point than where sine is. That's really what makes these two different functions. And if I'm at the max, I always go down to the midline, then to the minimum, then back to the midline, and back to the maximum. And that is 1 period worth of cosine. Notice how these are kind of curved shapes. It's not like a V. The reason why is the values get closer and closer to 1 as I get closer and closer to x being equal to 2 pi. So it's not a sharp connection, it's just a smooth curve. And then what I would do here is, because this is the same, I would take that same midline, same maximum, same minimum. My drawing isn't perfect, but that's okay. And then take that same midline. And our midline is at 0 because we did not move up or down. And then the last thing to kind of mention is that, notice the normal period to go from where you started, in this case for sine, it was midline, and then you have to go through a full cycle, max, midline, min, back to the midline. So once you go back to where you started, that period is 2 pi. It is a length of 2 pi. Right? And that's the same thing with cosine. This just happens to start at the maximum. So how long does it take before I get back to the maximum? Well, I got to go midline, minimum, midline, maximum. And it took x equals 2 pi to get there. So if we don't have any shifts left or right or any compressions, that's a b value, that means that the normal period is 2 pi. What we're going to do for this one is look at what effect does the 3 have on this function. So here's the way my brain works. When I see a function like this, I think, okay, this is y equals or f of x, it doesn't really matter, but I have a sine of b x minus h plus k. Well, notice the b value here, the b value is never 0. It's a 1. Technically, it would be kind of snuck in right there. So the b value is 1. The a value is 3. Okay, and then the h, you can put a minus 0 here. So the h is 0, which means I do not shift left or right. And you can always put a plus 0 at the end, and that's your k value. That's your vertical shift. So what do all these things tell me? Well, the amplitude is the absolute value of whatever a is. So in this case, a is 3. That means that's how high this graph is going to go. That affects my midline, or that affects my max and min. The period, okay, what's the formula for the period? That was 2 pi over the absolute value of b. Well, we know that b is 1, so that just means the period is 2 pi. So from that period, I'm going to go 1, 2, 3, 4. And because the period is 2 pi, that tells me my fourth tick mark is 2 pi. And then we can do everything like we did before. Nothing crazy there. We'll show you one where b affects it and how that changes these values. The phase shift, or another way to think of your phase shift, is your horizontal shift. Your horizontal shift is your h value. And in that case, h is 0, so we do not move left or right. And your vertical shift is the k value, which means we do not move up or down. So since I don't move left or right, I don't move up or down, the only two things I have to think about is the amplitude. And the amplitude controls the max and the min, right? But it also depends on where the midline is. So what I usually do first is I usually graph the midline. Okay? And what is the midline? That's your vertical shift. Right? Since I didn't go up and down, then we're going off the regular parent function. So the midline is at y equals 0, which is the k value. Right? Then I have to go an amplitude of 3. So I need to be up 3 units. So I'm going to go up 1, 2, 3. That's going to be my max line. But the amplitude also controls how far down we go. 1, 2, 3. So if my amplitude is 3, notice it's 3 up or 3 down, then I'll just put a max and a min line there. Okay, so I know that the highest value I'm going to hit is 3. I know the lowest value I'm going to hit is -3. So I would label this as my max is at the equation y equals 3. My min is at the equation y equals -3. And then the only thing, because h and k are 0, is where does sine start? Well, sine starts at the midline. And then I have to go, my next tick mark is going to be up to the max, down to the midline, and then the next one is going to be down to the minimum, and then back to where I started. And that is 1 period of sine. And then we usually just draw an arrow this direction and an arrow this direction. Now, what we usually like to do is draw 1 period in the positive direction and go 1 to the left. And that's just following the pattern again. So I'd make 4 tick marks and then label that. I'll do that on the next example. Okay? So that was the 3. Now I do want to point this out since I have this up here. What if I had a negative here? What would that negative do to all of these points? Well, it wouldn't change the 0, but it would reflect. So instead of going over pi over 2 up 3, it would go down 3, and then it wouldn't change this point, because if I make 0 negative, it's still 0. But what if I make -3 negative? That's going to make it a positive. So as we learned before, this green graph would be what sine would look like if a was negative. And all that is a reflection. Okay? So that's a reflection on the graph if a is negative. All right. Again, don't write this one. Let's look at what would happen if I had a 2 for cosine. Well, I'm going to treat this the same way, right? Actually, you know what? Let's make this a -2. Okay, what if I have a -2 there? So I have to look at what's the a value. A is -2. What is the b value? B is always the number out here, which is always 1 unless there's a number there. And then there is no h and k. So 0, 0. So the amplitude is the absolute value of a, which is 2. Okay, what is the period? That's the one where you just have to do a little bit of work. It's 2 pi over the absolute value of b, which if b is 1, then you know that your answer is 2 pi. So what does that 2 pi tell me? 1, 2, 3, 4. 1, 2, 3, 4. It tells me that I'm going to go 4 tick marks, and I can label those as much as I want. But the 4th tick mark tells me it's going to take a full 2 pi to get through one cycle. And then here my horizontal shift is 0, vertical shift is 0, so nothing really affects this, which means my midline is at 0 because I did not shift up or down. And then I would have to label that. Midline is at y equals 0. Now, what is the maximum? Well, the maximum is the amplitude. That's up to and down to from the midline. So I'm going to go up 2 units. So 1, 2, and down 2. And that would give me, this should be a that would give me then my max and min line. So at 2 and at -2 are my values. Okay, so my max is the highest I go is 2, the lowest I go is -2. Well, now, since I don't have any phase shift at all, I'm going to just say, well, where does cosine start? Well, cosine should start at the maximum, right? Cosine should start here. However, notice that negative? The negative is going to reflect all the points. So instead of starting at the max, cosine has to then reflect down, and it's going to start at the minimum. And then the next tick mark is always the midline, and then it's that same pattern. We're going to go minimum, midline, there. So minimum, midline, maximum, back to the midline, and then at 2 pi, I'm back to where I started. So this would be the first graph, the first period of -2 cosine. So what about going the other direction? I said I wanted to graph more. Well, we're just following that pattern. If I'm at the minimum, then I have to go to the midline, and it's the next tick mark. So the next tick mark over would then be at the maximum, and then the midline, and then minimum. And there's the second period of 2 pi, or excuse me, -2 pi. And there's our graph for cosine. Right? So it takes some exposure and some experience. Let's have you guys, you know what, don't write this one. I don't think you need to write this one. This one's just tricky. The only reason is it's degrees, right? But we can think of the same way as radians. So let's do this. What's the A value, right? A is 1. What's the B value? B is the number in front here, which is 1. What's the H value? Now this is the part you have to really be careful with. It says X minus H. So if I read it as minus 90, H is 90, and it's going to be a phase shift of 90 degrees. And since it's -90 in the equation, we're going to move everything to the right 90. So I'll show you that in a second. And then you can always put a +0 here at the end, which is your K. So there is no vertical shift up. And my amplitude then is the absolute value of 1. The period is just 2 pi over B, which is 1 or 2 pi. So nothing affects this. Our max and min are still 1. The highest I'll go is 1. The lowest I'll go is 1. The only thing that's going to change is I'm going to have to shift everything to the right 90 degrees. So I'll visually show you what that looks like. The only thing we have to be careful with is, okay, well, wait a minute. I just said that I kind of have conflicting pieces, right? I said I'm going to shift things 90 degrees, and I said my phase shift is 2 pi. So if I do 1, 2, 3, 4 tick marks, we always put 2 pi here, but if we're doing everything in terms of degrees, I'm just going to call that 360 instead of 2 pi. And then what if I cut 360 in half? That's 180. What if I cut 180 in half? That's 90. What if I cut the middle between 360 and 180 is 260. So we still have those 4 tick marks. And I still have my max line. Still have my minimum line. And that midline doesn't change either because I didn't move anything up or down. So now how do I graph with a phase shift, right? Well, think about where would cosine normally start? Okay, cosine would normally start right here. our normal start for cosine would be right here. But what do I need to do? I need to shift it 90 degrees. So I need to move one tick mark. And now here is my new start, which is a shift to the right 90 degrees. And that's it. Now that you know where you start at, I'm at the maximum, I go to the midline, then I go to the minimum, then I go back to the midline, and then I just need one more tick mark, which isn't horrible. You can throw that in there. Right? You could even label it. If I add 90 more degrees here, this would be 450, but that would put me right back here. And then all I did was just connect my dots. Oh boy. Yeah. Try this again. And then I can connect, and you can see there's one full period here again. And you can notice that the period length is still the distance between 450 and 90. So what if I took those and subtracted them? Ooh, this is getting kind of sloppy. 450 minus 90 is 360. So you can still see that it takes what we thought, 360 degrees to do one full period. All right, I would like to do this one together. And let's add a little extra piece here. We're going to have some fun. Okay, we haven't talked about phase shifts yet, and we haven't really done a vertical shift. So I would like you to write this one down. And I might even put a little extra space here. I don't really need the parentheses around here because it's just sine of 2x. But I did that so we can add a little extra in here just so you can see. And I'm going to try to do this with very thorough notes so you can get everything that you need. And we'll fill this out together as we go. So what do we have? We've got f of x equals sine of 2x plus 1. So when I'm doing this, the first thing I'm going to do is realize that there isn't an a value. Right? So I'm going to just state a is 1. Okay? Now, we do have a number on the outside. This is the first time that we've seen this. So I have a b value. The x minus h is not present. We just have x. So I can put a minus 0. I could even put a plus 0. It doesn't matter because that just tells me that I'm not shifting things left or right. All right? And then the k value is the plus 1. And I might even, right next to that, I might say this is going to move everything up 1 unit. Now notice, if I move up 1, wait a minute, that's my midline, right? So I automatically know from the k value, I know what the midline is. I'm going to give you a second to get caught. So let's deal with the amplitude first, right? The amplitude is the absolute value of the A, which in this case, that means I'm just going to be up 1 from the midline and down 1 from the midline. Now it's different because we do have that midline has changed. Okay? The period involves the B value. The equation for, that's what I'm trying to do, is write the equations for you guys here. So the period is 2 pi over the absolute value of B. Well, now notice, this changes, right? I know that B is equal to 2. If it was a negative 2, we would just consider it to be a positive 2 because the absolute value. Well, then what happens? 2 over 2 reduces out, and now my fourth tick mark is going to be pi, not 2 pi. So it changes the period length. Right? My phase shift is equal to h, and in this case, h is equal to 0. So I don't move left or right. We stay exactly where we were. And then the vertical shift is the k value. And in this case, we're going to shift everything up 1. I'm going to use green for that because that is my midline. So whatever k is, that's your midline. All right, so we don't need a super detailed graph, and I'm guessing a lot of us don't have graph paper at home, which is completely fine. We can still make a pretty accurate graph here. So what I'd like to do is, we know that we have an amplitude of 1, but my midline is 1. So I need to go, 1 is my midline, and then I need to be 1 above that. And actually, I might make this just a little taller. Doesn't really matter. So there's my midline, and if I have an amplitude of 1, then I'm just going to be 1 higher than that, right? But if my midline is 1, then I'm going to be 1 lower than that, which is 0. And that's kind of hard to write, so we don't need to put it there. So the next thing I'd like to do, we're going to draw in that midline. And if you have separate colors, it might be nice to do that. If we were in class together, I would kind of have some markers available and just have you do this. So your midline is at 1. Because we know the midline and the amplitude is 1, I'm going to change this color, but I'm going to go 1 above that. And that'll be my max line. And then I'm going to go 1 below the midline. So if I take the midline and go 1 below that, it doesn't show up perfectly. I'll put it off just a little bit. But now you can see where your max and min occur. So my max is at y equals 1. And my min is at y equals negative, 0. So notice, our amplitude tells me how far up I go from the midline. I went up 1, or I went down 1, but they consider that to just be positive. So there's my amplitude. The period, now we didn't do anything with the period. So this is where the 4 tick marks go. Now, we can't put them up here. And that's the one thing that a lot of students try to do, is we can't put them up here. They have to remain on the x-axis where they were originally. So I'm going to put 4 tick marks, but this time the 4th tick mark is pi. So what if I cut pi in half? Then that's pi over 2. Right? That's all I did was if I have 4 tick marks and it's pi, then cutting that in half is pi over 2. Well, what if I cut pi over 2 in half? That's pi over 4. So every tick mark is a fourth of pi. So here's 1/4, 2/4. This one that we didn't label would be 3/4 of pi, or 3 pi over 4. Okay. And since we don't have a phase shift, since I don't move left or right, then I'm just thinking, where does sine start? Sine starts at the midline. So my midline is the green spot. There's my start. And since it's a positive a value, I'll go to the max, and then the midline, and then the minimum, and back to the midline. And that is one cycle pi. You don't have to draw this, but visually, look at the period. How far is it? We started at 0 and we ended at pi. So if I just subtract those, pi minus 0, see how that period is a length of pi? And that's exactly what the equation gave us. All right, so we saw how B affected the value, we saw how A affected it, we saw how K affects it, we even saw how H affects it. So what if I changed this A value to a 5? What would be the difference? Nothing, except for instead of going up to 2, I would have to go 5 units up. So I'd go up from 1, I'd go up 5, so my max would be at 6. And then if I'm already at 1, my min, I would have to count 5 units down here, and I'd be at -4. So if the amplitude is different, then that's going to tell us how far we are away from the midline. So it's very important to basically do the midline first, and that will set your max and mins. All right, so what are you going to be looking at? We're not going to do all of these, we'll just do a couple. So some of your homework tonight is just on Delta Math, is just determine the period. So determine the period of the following trig functions. I want you to write down this first one. Okay? So what do we know about the period? Right? Determine the period of the following trig functions. Well, when we say that, what you have to know is the period is 2 pi over the absolute value of b. You have to use that equation, which tells you the only thing you need is the b value. I'll give you a second to get caught up. All right, so it's just important to think about, wait a minute, what is the b value? So we define the b value. So then if I'm going to find the period, I'm going to plug in what that b value was. 4 pi over 5. Now we run into a not super friendly piece. I've got a number divided by a fraction. And if you remember, we don't like to divide by fractions. I like to multiply by the reciprocal. So I'm going to change this to 5 over 4 pi. Notice it's division, and then we change it to multiply. I want to just make that a fraction. And then if we use our rules with fractions, we're going to multiply across, but wait a minute. I've got a pi on top and a pi on bottom. Those are going to reduce out. I also, now you could call this 10/4 if you want, or you could have divided the 2 top and bottom, so you would get a 1 over a 2, and then that automatically reduces. 1 times 5 is 5, 1 times 2 is 2, and the period is 5/2, which isn't super friendly, but that's what it is. Okay, really quick, you don't have to write this one, I just want to show you another example. Here's my b value. What would I do? Period is equal to 2 pi over the absolute value of b. Well, now notice 2 pi over 2 pi, those reduce all the way out, which means the period would be 1. Okay, and then what about this one? Just quick. Don't write these. I'll do them very quick. So period is equal to 2 pi over, here's my b is 4, and we get 2 over 4 is 1/2, or we could write that as pi over 2. Okay. And then this one again is just another fraction. I've got the b value is 4/7. But this is one of the ones where if I divide by a fraction, we want to change that to multiplying by the reciprocal. And then what I would do, you could call this 14/4, but I would reduce a 2 out here and a 2 out here, so I'd get 7 pi over 2. Okay, so nothing but fractions. All right, so we got about 9-10 minutes left. I have some problems that I just wanted to show you how, because these can be tricky, and this is what your homework's going to look like for Delta Math. So your job is to take the graph of cosine. And this black original function is the cosine graph. How do I know it's cosine? Because it starts at the max, right? And then what you want to do is you want to think, well, wait a minute, how do I have to match? I want to fill in these values for A, B, and then notice they don't have the H, so they're going to tell you H is 0, and then K. So how do I fill these values in? Well, the first thing you need to do is identify the midline. Right? And K is the midline. So where is my new function? Here's my midline right here. Right? How do I know that's the midline? Because it's equally spaced above and below the max and mins. Well, where is that midline at? The midline is at the equation y equals -4, which, remember, the midline is your k value. So I'm going to put a k in -4 right there. The a value is pretty easy to find because that's your amplitude. So all you're doing is looking, how far up from the midline am I? Well, my max line was at -3, and from the midline, I just went up 1. So a is equal to 1, because that's the amplitude. It's how far up or down we go from the midline. Okay? So then the hard part, or the tricky part, is finding that b value. So the b value has to do with the fact that we know the period. But we're working backwards. Now I have to read, okay, wait a minute. How long does it take for cosine to go through one period? Right? How long does it take to go from max back to max? Well, notice you could look on the original function as well. How long does it take? It takes 2 pi. So the period, the distance from here to here, the period is equal to 2 pi. So I'm going to replace this. That's not the b value, right? 2 pi is equal to 2 pi over b. Now we can remove the absolute value because these are all positive. And then I'm just going to cross multiply, right? Or you can think of this, well, wait a minute, 2 pi over 1, what does b have to be? It has to be equal to 1. But if you cross multiply, that will always work. So I get 2 pi equals 2 pi times b. And then if I divide by 2 pi, the 2 pi's reduce out and I'm left with b equals 1. So that's usually the spot where kids struggle. They're good with finding the amplitude and the midline. They struggle with that a value, or I'm sorry, the b value, and that's working backwards. So let me show you another one. You can definitely see this one is a little higher So what I need to do is I want to think, well, wait a minute, I'm at 1 and I'm at -5. My max on this dotted line is 1. So I want to find what's the middle value of -5 and 1. Well, I could guess, and guessing sometimes gets me where I want to go. So if I guess -2, how many units am I above? 1, 2, 3 would get me to the max. Is that the same thing to the min? 1, 2, 3 would get me to the minimum. But I don't like the guessing game, even though in this case it's kind of easy to see. Right? To the max, I went up 3. To the min, I went down 3, which means my A value is 3. But what if I didn't know that? How would we find that? Well, take your max line, which you know the max line is at 1. Take your min line and find the average of those values. Right? So here I'm at y equals 1. And here I'm at y equals -5. Well, where is the A value? The A value is the difference between those. So if I do 1 minus -5 divided by 2, that's 6/2, or wait a minute, it didn't turn out right. Sorry. I want to find the average. I have to add them. I subtracted. So what do we get? We get -4/2. There's my midline. All right, so midline is at -2, and that is your k. Right, so k is equal to -2. And then the last thing we need is just that b value. So how do we do the b value? That's where you find the period is equal to 2 pi over b. So how long does it take to go through one full period? Now you can use the original value, or you can use this dotted line, but how far does it take to get to right back here? Well, that's one full period is 2 pi again. So it's the same work we just did. I'm not going to go through all that, but 2 pi would be equal to 2 pi over b, and the only thing that b has to be is 1. Right? You can cross multiply, and you'll get the 2 pi's to cancel out. I want to get to, I think this is the last one. Let's see. Okay, this is the last one we'll do together. Don't write this, but this one has a different period. So here's what I'd do first. Where's the midline, right? Well, the max is at 0 and the min is at -2, so the midline is the middle one in between. That one's pretty friendly. Which is the k value, right? So that tells me that k is equal to -1. The A value is your amplitude. Well, how high do I go up? I go up 1, down 1, so the A value is 1. And then how do I find the period? Well, look at the original graph here, or excuse me, the new graph. How long does it take to go from one spot to the next? And in this case, my period length is equal to pi over 2. So what I need to do then is I need to take the fact that the period equation to find b is 2 pi over b. And since these are all positive, I don't have to worry about the absolute value. Now we're going to cross multiply. So I get pi times b equals 2 times 2 pi, which is 4 pi. And then I'll just divide. My goal is to get b by itself. Pi's reduce out. And the b value, ooh, that got messy, is 4. Okay, so nothing super crazy there. All right, so homework tonight is Delta Math 4.4 day 1, and then submit a screenshot. If you need help, I'll be available in my office hours from 1 to 2 today. Okay, have a good one. We'll see you later.